So continuing with this number line, we had just noticed that our one whole from 0 to 1 is broken into 10 equal pieces, or tenths. So we could very easily think, well, this is 0 whole and 1/10, which would look like 0 whole dollars and 1/10, or to make it look like money, 10 cents. So then this would be $0 and 2/10, 0 and 3/10, 0 and 4/10, 0 and 5, 0 and 6, 0 and 7, 0 and 8, 0 and 9, and then that would bump us up to 1 whole. Now, the problem that we were noticing here is that if we want to know that letter C is worth 0 and 38 hundredths, or if we think money, this looks like $0 and 38 cents. How is it that they're getting that if our number line only says 0.3, 0.4? Or some of you may be sitting there going, how in the world does 38 fit in the middle of 3 and 4? Well, that's because you've got to always go back to thinking money. Blank wholes and blank cents. So, this is not a 1, a 2, and a 3, and a 4. This is a 10 cent, 20 cent, 30 cent, 40 cent. So, 38 cent is very close to 40 cent, which is why C is worth 38 cent. So, for example, let's look at F, way over here. We're looking for something that has 0 wholes, and this is not, remember, a 9. It's 9/10ths, so we're thinking 9 dimes, or 90 cent. So we're looking for something that's close to 0 and 90 cent, and if you look really closely, it's just a little bit past that 9/10ths, or 90 cents. So first of all, we want to go and look for 0 holes. So down here, we're looking at the ones with 0 holes, and then we're looking for one that is just slightly bigger than 9/10ths, or 90 cents, which would give us this one over here, 91 cent. Alright, so E is really easy. Maybe that's why they chose E. E for easy, because it's right on the 7/10ths, or if we think money, 7/10ths of a dollar is 70 cents. We've got to have 2 past that decimal. Always 2 past the decimal if we're thinking money. Got to have 2 after the decimal. So, E for easy is going to go to $0 and 70 cents. Alright, let's look for some more. How about this one, letter A, is just barely past $0 and 0 cents. So we're looking for, of these zeros that are left, something that is just barely more than having absolutely no money. So you're looking at $0 and 25 cents, $0 and 2 cents, $0 and 54 cents. So it's in between having absolutely nothing and having $0 and 10 cents. So we would go with, what do you think? Correct, 0 and 2 cents, or 2/100ths of a dollar. Alright, so letter B is going to fall in between not 2 and 3. It's not 0. Well, you could call it 0.2, 0.3 if you're thinking tenths, but because you're thinking money, you're thinking 20 cent and 30 cent. So what's in between 20 cent and 30 cent? And to be exact, it's directly in the middle of 20 and 30. So that'll give us 25 cents. Alright. So D would fall in between the 0.5 and 0.6. If we're thinking money, it's $0 and 50 cents, $0 and 60 cents. So letter D is going to be over here, $0 and 54 cents. It would make sense for this to be $0 and 54 if we're in between 50 cents and 60 cents. Our only other one on this side, oh, we've got all the ones on the $0 side. Alright, so now let's take a look at all the ones that go past $1. So G, H, I, J, K, and L are all greater than one whole dollar, which is why all these money amounts down here that are left are all greater than $1. Alright, now, again, if I think my chocolate bar, I want to think this number line is broken into a chocolate bar pieces. So G is a little bigger than 1/10 or one piece past $1. So this would be 1 and 1/10 because that's my tenths place. And if I'm thinking money, I can add in my ghost 0 there. But it's not quite a full 2 pieces past. So my next line would be another piece past. So there's 1/10 and 2/10. So this next line would be $1 and 2/10. And again, it takes 10 dimes to make $1, so we're thinking dimes or 20 cents. So what number down here would fall in between $1.10 and $1.20? How about this one? How about 1.29? Will that work? Hopefully you're yelling at me saying no, or you're sitting in your seat going, I'm really confused now. Because that's wrong, because there's no way that $1.29 can be in between $1.10 and $1.20. So that is incorrect. The correct answer would be $1.16, because 16 fits in between 10 cents and 20 cents. Alright, so now we're moving on. If we have another piece past, we're looking at 1 3/10 or 30 cents. So then H would be just a teeny bit before that 130. So this one would be H. Then we have another piece, $1.40. Right in the middle, $1.50. So J is actually pointing directly in the center of $1 and $2. So J would be our $1.50, which makes I just a little smaller than the $1.50 mark. So where would we be looking here? $1.47 would be just a little smaller than our $1.50. So then we are left with K and L. And if I just want to think about the number value of this, L is closer to $2, so it's going to be a bigger number, because just like your normal whole number lines, 1, 2, 3, 4, 5, 6, 7, the further you go this way, the greater your numbers get. So between $1.75 and $1.83, L has to be $1.83 because it's closer to $2, and K has to be $1.75. Or we could continue with our labeling of our tenths: 1.6, 1.7, 1.8, 1.9, $2. And again, we don't want to think of these as 6s and 7s and 8s and 9s past there. We want to always think money. We need another digit past. So we want to think money. $1.60, $1.70, $1.80, $1.90, $2, which again proves K is directly in the middle of $1.70 and $1.80, which gives us $1.75. And then of course the same strategy can be used below on this fresh number line. The only difference is, instead of looking at 0 holes, 1 hole, and 2 holes, you're looking at 5 whole dollars, 6 whole dollars, and 7 whole dollars. And using the same strategy that we used above, you should be able to figure out where these values are on our number line above.